Hello, my name is Widenius, and I want to do a quick introduction to MindsDB. But first, a short recap of why one should use AI instead of statistical methods. Statistical methods are great for showing views of small data sets, but it's not very good at predicting things based on all data, or work with data that has dependencies that you don't know of. For these cases, AI is a great tool. When looking at MindsDB, I'm reminded of how MySQL was originally created. It was created to analyze customer data, and which we stored in MySQL, and then we exported it to SAS and other statistical tools to analyze the data and find patterns in customer behavior. If we would have a MindsDB back then my work would have been much easier. When it comes to start using AI, there is some obstacles. First, if you're not an AI expert, you need to decide on which AI algorithms to use, which tools to use, and you have to learn a lot of new things. And it takes time. It's always an obstacle to start using something new. And when you start to use AI for data analysis, there's some steps that you have to go through. You have first to start cleaning your data from all nonsense like wrong user input or abnormal values and stuff, because that will change the predictions, and these are things that you're not interested in. Then you have to take your data and move it to the AI system for training, and you usually have to train it multiple times with lots of data. And then when you start to use the AI, you have to reuse it with different configurations and options just to find out more about your data, and you have to learn more and more about the new tools. And then you have to examine the result, and you have to store it somewhere that you can share it with others. All this MindsDB makes incredibly easy. You just start by installing MindsDB, which is the Python program. Then you create a config for MariaDB, and then you install the Connect engine if you don't already have it. This should take a couple of minutes, and then you are done. And the nice thing with MindsDB, you don't have to move the data somewhere, because you probably already have the data in MariaDB. And if you don't have MariaDB, then maybe it's time that you install it now. And training is done with a simple insert SQL query. It couldn't be easier. And the nice thing with removing nonsense is that you only have to add a where clause where you can choose both what you train with and which dataset you are interested in. It's trivial to run analysis on different segments, because it's just, again, editing a where class that you already know about. And storing the end result is also easy. You just do a select into out file, and then you have data in a format that is easy to do. And of course, you can even store it in another table directly. Now Jorge and Vicentiu will present the new features in MindsDB. I hope you will be impressed, and hope you will start using MindsDB together with MariaDB soon. Thank you.
Hi, my name is Jorge Torres. I'm the CEO and co-founder at MindsDB, and I'm here with my coworker Patricio Cerda and Vicentiu Ciorbaru from MariaDB. And we're going to talk to you about the machine learning capabilities that we're bringing to MariaDB. So let me start with the intuitions that led us to think that machine learning perhaps fits better at the data level. Today, there are so many databases and so much data in existing databases. However, we still treat applications and machine learning as part of the same stack, or the building block. However, if your data is already in the database, it makes sense to perhaps see it in different way. Let me walk you through why we think this is the case. There are so many similarities, or to put it another way, machine learning models are intertwined in a very specific way with the data that you train them from. And if this data is coming from a database, you can see a lot of parallels. Like in data models, you have the schema that defines, how your data should behave. And then in machine learning models, you have the graph that defines your model. Now you fit data into the schema in the data model, and that's what populates your database. And on the other hand, you actually fit your model to the data that you're training from, so that it kind of like essentially adapts the graph to fit that data. And then lastly, as your data changes, what you will expect is that your models change the same way. So that the distribution of the data should be also changing in the same way, or the model should be changing in the same way that the distribution of the data does. Now, when you start thinking of this intertwined relationship, perhaps the question that you should ask yourselves is, does machine learning live in the application layer, or does it live in the data layer? And remember that stacks within applications are varied, but usually people develop a full-blown application for machine learning, and that has two downsides. The first one is you end up reinventing the wheel in a lot of stages of the data preparation and ETLing when databases are the best place for you to do this. So when you treat machine learning as part of your application block, then you end up essentially reinventing some of these capabilities unnecessarily. The second part is, once you have a machine learning model, you want to be able to move this model into production. And what most people end up doing is that they end up wrapping those models around some sort of web service. And now you have to not only maintain the model, but you have to maintain all that infrastructure to keep your model running in your web service infrastructure. And lastly, once your model is in production, you also have to do some transformations to fit your data into the model, and then get news predictions out and some form of ETLing again back into your data warehouse, where you're going to use those predictions wherever you need them in the application. Whereas if it was part of the data layer, you could query for data the same way as you query for predictions. Let me give you an intuition that we have as to how to simplify all of this machine learning infrastructure in a way that allows you to see it as part of the database layer. So imagine that you have a table, a very simple table. Most tables don't look like this, but for the sake of this example, a table that has income and debt. And if you ask like the database about a specific match, then of course you're going to get a result. So if you ask for what would be the debt when the income is 80,000, you definitely get a match, and therefore you get a response. But if you make a query, even if your query is very close to one of your data points, you're going to get a null. Say, for instance, for 90,000. Now, anyone that has done machine learning understands that you can actually build a machine learning model that fits this data, and it will look more like a line like this. And if you can query that line the same way that you query a table, then essentially the abstraction is there. So the ability of portraying machine learning models as tables is what we bring here into the equation. So you could query that line, say, well, when the income is 9,000, you're actually going to get a response. Now, this intuition is actually something that we really want to provide for you. MindsDB allows you to create predictors and to share them with other people through the same concept as a table. So you can query a model the same way that you query a table. I'm going to hand it off to Patricio and to Vicentiu, who are going to walk you through more details into why this is important and some of the very important challenges that now that we're doing this abstraction of machine learning models as tables that are probably dominant in the space of databases and the data that you have in the database that we solve for you. Stay tuned.
All right, thank you, Jorge, for the great introduction. Now I will talk about the integration part of MindsDB in MariaDB by looking at it from the MariaDB perspective and potentially the DBA or application user perspective. So first of all, why would you want to use database AI inside the database? Like as Jorge mentioned, a database is very well suited for preparing data. And what this means is that you have all the right tools to clean your data and transform it the way the machine learning model gets the best chance to train on and produce you meaningful results. So you can do filtering to clean up rows that are, let's say, out of the expected values, or clean up garbage data. Then you can also do aggregation like group by, and with group by, and then getting averages, minimums, maximums, etc. And then you can augment your data. Of course, MindsDB, being a AutoML framework, kind of does a few of these things for you, but the better data you give it, the higher the chance of it training a better model. And the database is well suited for preparing this data. And now the advantage of using MariaDB is that MariaDB has storage engines which extend the traditional database functionality past the read and write aspect. So what I mean by this is that when you create a table in MariaDB, you can use a specific storage engine to use that will handle all the inserts and selects and deletes from that table. But that's not where the whole thing stops. When you insert data into a table, it doesn't necessarily mean it needs to go to disk. It can actually go over the wire to a different server. And that's where the connect storage engine comes in. Also, when you select data from a particular table, it also doesn't have to go and get it from disk. It can be computed values. And that's where the MindsDB integration comes in. And all this is nice, and we're going to see how all these tie together. But the other advantage is that because you're using the tools you're already familiar with, which is traditional connectors like the C connector or the Java connector or the JavaScript connector, or maybe you're using frameworks like Django, which themselves generate selects for you. You don't have to add another tool to your stack. So no extra tools. You just have to set up MindsDB and MariaDB, and you have tables ready to go. From the MariaDB perspective, the setup is relatively straightforward. You have to install MariaDB server, and then you have to install the specific plugin, the connect storage engine. Depending on the distribution, the commands might differ. You can go to mariadb.org/download. There you will have a repository config tool, which will give you all the right commands to install MariaDB server. Besides installing the server and getting it started, we need to connect to the server and set up a specific MindsDB user. Now, we need to create this MindsDB user because MindsDB will connect to MariaDB to get the data we're after. So we're going to create a user. We're going to give it a password. We're going to grant all the privileges that it can have on a special database called the MindsDB database. Then we're going to grant the file privilege, otherwise the integration won't work as well. So the file privilege needs to be granted on the global level to the MindsDB user. And then make sure that the MindsDB user has access to all the data you want to use for training. So grant select on everything that's interesting to this user. That's all we need to do on the MariaDB side. On the MindsDB side, we first need to install MindsDB. There's multiple ways to install MindsDB. One of them is the one I prefer, and that is to use the Python package installer to install MindsDB. So just run pip install MindsDB. There's quite a few dependencies and there's a bit of compilation, so it takes a while. But assuming you have all the dependencies installed, this should work flawlessly. If you don't have all the dependencies installed, you might have an easier time running the Docker container for MindsDB, which MindsDB has prepared, but it is quite of a big download of around a gig and a little bit. So take your pick. And then once it's installed, before we start up MindsDB, we need to give it one single set of instructions on how to connect to MariaDB. And this is an excerpt from the config file that MindsDB uses. Here we specify that this is the integration type with MariaDB. It's listening on this port, and this is the host that it's going to connect to. and this is the user and password it's going to use to connect to MariaDB. And this should be the user and password that you defined previously for the MindsDB user. And finally, we start MindsDB. And now let's have a look at and see how it works. Now the whole setup process from before should make sense now that we will see how MindsDB first starts by connecting to MariaDB with the MindsDB user. And then it will create a MindsDB database and also the special AI tables, commands, and predictors. We're going to see them in a little bit during the demo. And now these tables, what they do is they give you an interface of how you can give MindsDB commands. And the first command that you probably want to give MindsDB is to start training a model for you. So you do that by inserting a special statement inside the predictors table, and then MindsDB gets to work. And what I mean by this is that it will create this predictor table by getting the select statement that you've passed during the insert statement from step number 4, and it fetches the data from MariaDB into MindsDB. Now the data gets passed to MindsDB using the MySQL/MariaDB text protocol. So there is a bit of overhead if you're sending this across the network. Make sure that the network isn't the bottleneck for moving data over to MindsDB. And then once everything is done, you're going to have the predictor table ready. And then the user can just start querying it with select statements. And that's all there is to it. Without wasting too much time, let's go into the demo and see how everything ties together. And here we are at the terminal. Let's have a look at what I am running here. So let's first see how we can install MindsDB. Now I have a virtual environment on which I've already installed MindsDB, but you can install it with this simple command. And if you run it, it's going to take a bit of time, but it's going to work. And then the final thing, before we start MindsDB, we need to check out the config file and make sure that it has the correct configuration to connect to MariaDB. And notice this integrations step here. Now here, with this integration step, we tell MindsDB to connect to the localhost server on this port with the MindsDB user and the MindsDB password. The data that MindsDB stores is inside the ./storage folder. And this is how MindsDB gets the data from MariaDB. The other interesting part is that MindsDB behaves as a MySQL server, and it does this by emulating the MySQL protocol, and it does this by allowing other servers to connect to it with a particular user and a particular password. And this is the setup that MindsDB uses. And now let's have a look at what happens when we use it in practice. So I will start MindsDB by just saying Python -m MindsDB. This will start the program. It takes a little while to boot up. But until it starts, let's have a look at our MariaDB setup. So here I am running MariaDB 10.6.0. The current user is not related to the MindsDB user, but I have all the rights. So let's see. So I have all the privileges on all the global privileges. And now I've already created the MindsDB user. So if I show you the grants for MindsDB at localhost, we see that I have the file privileges, and this is the password, the MindsDB password. And then I have all the privileges on this special database called MindsDB. And then I have all the privileges on the test database and the statistics database. The test database is important for this example. The statistics I used previously for trying out a couple of other models. But for the test one, so if we look in test, we have a table with used cars data. And this table has a couple of columns that show a particular model of a car from the year of manufacture, what price it was sold for given the current used parameters. So let's have a look. Select star from used cars data, and where the limit is 2. We see we have a couple of examples of Audi models, one from 2017, one from 2016, and they were sold for 12,500 or 16,500 with these mileages attached to it. Okay, so we want MindsDB to learn from these examples and help us predict other used cars, what prices they might sell at, or they should sell at. And the way we do this is we go to MindsDB database, and let's see what we have here. So we have here two special tables called commands and predictors, and these are the interface tables to MindsDB. But we also have the used cars model, and this is a model I've already trained. We're going to have another one, and we'll see how that one works. But in order to start training, we need to do an insert. Now, I've already taken the command here. So what we need to do is we need to insert into MindsDB predictors. This is the name of the predictor. We're going to call it live training demo. And we want it to predict the price column. And this is the select statement that I want MindsDB to use to get the data for training. It's kind of like going backwards and telling MindsDB, here's how you get the data, you go get it and do your thing. So I tell MindsDB to start training by giving it this statement. And now MindsDB is busy. Notice that I'm already getting logs of it taking a sample and trying to analyze it and then trying to figure out what the best way to train on it is. But because this takes quite a bit of time, maybe around 30 minutes or so for this particular data set, we can already use the one I've tested to do a couple of predictions. So we're going to select what we can predict is the price column. So we can select the price. We can also ask MindsDB to give us a little bit of an insight into why it predicted some things. So we can do price confidence. So it will tell us how confident it is in this prediction. And then we can also select a couple of columns that are just so we have a nice view of the data. We can select the model, the year, and the mileage. All of these three columns we're going to specify ourselves. So used cars model. So I'm selecting from MindsDB used cars model, and I'm going to give it some values on which to predict. Now the model is going to be in a, let's say we're going to predict the price of a Ford Fusion. Why not? And with the mileage of 100,000 and the MPG of, let's say, 35. And I've also forgotten the year. Let's make it a car from 2016. The more of the data that I can fill in, the better the prediction is going to be. But let's give it a try with these entries here. And let's see. Notice that MindsDB is busy training data on this side. And I made a typo. Yes. So we need to select from MindsDB. And the result is we expect the car to be worth around 903,012 I'm going to assume these are pounds because the data seems to be taken from the an UK data set. And it's rather confident in this price, but we can get even more information out of it. So we can get a better description of this by let's see, show create table, MindsDB used cars model. And these are all the columns we can query, but notice that we can get an explanation for the price. So there is this price explain column. And did I mention the connect engine? Of course I did. All the MindsDB models, when they create a predictor table, they will use the connect engine and connect to the MindsDB fake MySQL server. So notice here that the connection type is of type MySQL, but it's connecting to this port here that was specified in the config file. So a bit of a backwards and forwards, but if I've given you these details so you understand how things work behind the scenes, but when you're actually using this as an application developer, you don't really have to care. You just need to keep it in mind when it comes specifically about network performance and similar aspects. But still, I can ask MindsDB to give me an explanation of this. So let's also get the price explanation. Price explain for this exact model. And it's telling me that there is an important missing information. So I failed to specify the engine size. And that is relatively common because the cars tend to be also based off of the engine size. If I were to increase the mileage by, say, 50,000 miles, I would expect the price to be a bit lower. And of course, we are losing some value from the price. But then if we're also specifying a rather big engine, so let's say engine size is, let's say 2.5 liters, maybe this is one of the faster cars. And if we specify this, we're going to see that the price is actually increased by quite a bit. Then again, we're also getting no important missing information. We can also expect that if the year is quite a bit older, let's say it's a car from 2013, the price should also decrease. And lo and behold, the price nearly decreases by a third, because that's usually how price cars work. We can have a relatively good confidence that the prediction is pretty good, but we can't always rely on this number, so that's why we have an interval of confidence here. And here's the confidence interval between 6,500 and 1,500,000. All right, that's all I wanted to showcase on my end. I'm going to leave it for Patricio next to show you a more advanced machine learning example. And in the meantime, we're going to have the MindsDB worker finish training. In any case, thank you, and off to you, Patricio.
Okay, thank you, Vicentiu. My name is Patricio. I am one of the machine learning engineers at MindsDB, and I'll very quickly walk you through one of the advanced use cases you can delve into with our solution, which is multivariate time series forecasting. Okay, so we will start with a simple example as a motivation. So imagine you have access to flight records for all of the US. And so what this means is you've got information about each flight regarding, among other things, what carrier or airline was in charge of each flight, what was the origin, the destination of them, the distance between the 2 points, and in particular, whether the flight was delayed or not in its departure. So a natural question one might ask is, if you're dealing with, getting predictive insights about the data, would be, can we forecast the delays in departures? Now, there are several ways that you could cast your data to answer this question. In particular, one of them could be to aggregate the data by carrier. So you group your data by carrier, and then you plot it through the time, and you effectively get a bunch of time series, which show the evolution through time of the departure delays, like the amount of flights that were delayed each day for each carrier. As you can see here, picking any arbitrary pair of series will yield a lot of differences in the dynamics, in the temporal dynamics of each of them, which means they're not really the same series at all. And this I think encapsulates a lot of the challenges that have to do with forecasting for time series. When you assign a team of data scientists or machine learning engineers to forecast in this context, they have to be aware when building a data pipeline that you might have not only a dozen time series, like shown in this plot at the right, but depending on if we also consider, for instance, the origin and the destination of each flight, you could potentially have thousands or tens of thousands of different series. And this high group cardinality can be a challenge because training machine learning models is expensive. And you want to be not only efficient about the use of resources, but rather you would like to leverage the possible relations between series so that your machine learning model is going to be more robust. And this is all a challenge. And the good news here is that MindsDB has been able to automate most of this process. Starting with the initial phase of the pipeline, which could be, the data preprocessing step, right? So what normally a data scientist would do for treating time series is to store statistics for each of them, the relevant features or characteristics of each of them. And this is, of course, for each different group combination that is yielded by the way you aggregated the data. And then the series would be normalized using these statistics because, as people in the machine learning community know, these models tend to do better when you normalize the input values, right? And this is, in effect, what MindsDB does. Our mixer, which is a concept I'll develop in just a bit, learns to predict from and to normalized values, which is very convenient because we can leverage all the series at once. So our mixer is truly the actual machine learning model that is tasked with predicting the quantity that you want to predict. But we have a previous phase in this model selection building phase, which is to treat every single column in your dataset through an encoder, which will try to find a distilled representation of that part of your data, be it a temporal or non-temporal feature. So as you can see in the figure up here, you would have all features that are not temporal in nature, and they will be fed into the mixer. But crucially, for time series, we have a special treatment, which is, as I was mentioning, to normalize the values, but also to infuse a stronger notion of temporality, in this case with an encoder that is a recurrent neural network. So then at the end, the mixer, behind the scenes, right, has to learn to predict for the quantity you want to forecast. So we have two flavors of mixers. On the one hand, we have a neural network mixer that for time series in specific, both learns an autoregressive process that basically uses the previous values in a series to yield a sort of a base prediction, like a baseline of sorts. And then over this, we have a secondary stream that uses, of course, a neural network to fine-tune this prediction. But then the other flavor of a mixer would be our gradient booster mixer, which is not really based on neural networks. Rather, it uses features that might have been developed by a neural network, but also by other types of encoders that we have. And in this case, we resort to using LightGBM, which is a very powerful open source library. And in fact, we also leverage Optuna, which is another open source library for a very thorough stepwise hyperparameter search. So these two flavors of mixers complement each other quite well. And this means that you can be certain that for the predictive task that has time series in it, we will try to come up with the best machine learning model that's possible. Now, of course, the idea would be to use this as MindsDB thinks is the most convenient, which is from the database, right? In this case, from MariaDB. And we will see this in more detail in a demo that I'll do in a few minutes, but the main idea would be to insert a predictor by describing what you want to predict. Of course, giving a name to the predictor. There we go. Giving a name to the predictor, specifying the target column, giving a query that will retrieve the training data for you directly from your data schema. And then the only difference from what Vicentiu presented would be to define the actual time series settings, which are quite important because you're indicating the time series to the MindsDB time series pipeline that you will order by a certain column, you will group by another set of columns, and then you want to use a certain number of rows as historical context, and also you want to predict a certain amount of rows. In this case, we want to look back 10 rows to predict the following 5. Then to query, once the model is trained, you have two options. You can query a specific data point, so conditioning, in essence, that you want to forecast the delays from this predictor whenever the date is such. And this is useful, but when you want to predict at a bigger scale, you probably want to do a batch prediction. And the way to do that would be to select from your testing data the relevant columns, and then from the predictor, the forecasted values, and you just join them. This returns a table, and if you notice in all three pieces of code, we have treated the machine learning model as data, which is sort of the central concept here. Now, once you've got your predictions, you can visualize them with several different tools. Here I have some custom-made plots that we use internally. And in green, you have the actual series for the carrier WN, in this case, which represents the daily amount of late departures nationwide. And then in purple, you've got what MindsDB forecasted for the following day. So in essence, what this plot tells is whatever point you choose, say for instance this one, the purple line will be what MindsDB predicted using all the previous values up to that point, and the green line will be what actually happened. So you can see that predicting for the next day, in this case, the predictor is actually doing a decent job, right? And not only do you receive a point prediction, you also receive a lower and upper bound based on a confidence estimation that we make, so that you can also sort of detect anomalies, which might be present in the inherent dynamics of your series. So in yellow, like the vertical yellow lines here, represent points that fall outside of what MindsDB expected, and so are tentatively tagged as anomalies. And in here, when this happens, the decision maker can take a closer look at the data and determine whether or not this is an actual anomaly. But the powerful thing about this predictor in particular is that you can truly leverage the fact that you trained for all series and also predict for all series. So in this case, with the same machine learning model, you can forecast, in this case, for 4 different carriers, the amount of late departures. And if you had 100 different groups or possible carriers, you could forecast for all of them, right, with the same machine learning model. And so this is very convenient. Without leaving the data layer, you're able to, group your data in a certain way, and then for that dimension, you can forecast and obtain insights about your data. Now, something that's also worth looking at is when you forecast for longer horizons, like what is the added value here? And you'll notice this is a different task, but the peaks in the series and the valleys are actually modeled by the predictor well in advance. In this case, we're predicting in hourly intervals. So you can see the peaks coming even 12 hours in advance, which is useful if you are the person behind doing the decision making, right? So that's in a very short amount of time how you can use MindsDB for time series forecasting. I'll now jump into a quick demo, and then we will be happy to answer any questions at the end of the webinar. Thank you. Okay, welcome to this short demo that will delve a little bit deeper into the commands that we just saw for operating MindsDB through MariaDB. So right now I am in the MariaDB shell, as you can see, and let's take a very quick look at the data that we have. You can see I've got lots of tables here with different data sets. Lots of them have to do with the on-time data set, which is the one that we have been showing in the presentation. So for example, if I select, let me try that again. If I select this like this, you can see we've got lots of information fields for each different plane that, in this case, it departed the 30th of December of 2019 and so on. So lots of information. But really what we want to do here is we want to use only certain columns for this prediction in particular because we decided to do so. In this case, we will only work with the date of the flight, the carrier, and we have grouped the delays. There's a specific column that is binary. And so a flight is delayed if it departed over 15 minutes past its scheduled time. And so what we've done is we've grouped by the carrier and by the date and summed all of the delayed flights, thus giving us the time series that the previous slides showed. So now we want to predict or forecast for each of those series using MindsDB. So the first step is to actually go to the automatically generated MindsDB database. And then what we have to do is we have to insert a command, which is the one we saw in the presentation. So we're giving the predictor the name airline delays. We're asking it to forecast the delays column, extracting the training data set from the table that we have to an extent, pre-processed. And in this case, ordering by the flight date, grouping by the carrier, and having the 10 last rows for each group as the historical context. And well, in this case, I have already pre-trained a predictor for this because even though it takes a couple of minutes, I don't want to wait. So let's just train the airline delays #2 predictor. Now, if we select all the predictors that we have in MindsDB, you can see here that we now have one airline delays #2 predictor, which is currently training. Okay, but we already have a pre-trained one with quite a high accuracy, which means it's a good forecaster. So now we will take a look at that. In particular, we want to predict using the batch prediction method, which is what it was the second option that we saw in the slides. And the way to do that is actually, let me open a new terminal for this. So to do this, to predict a batch for a batch of your data, we will select from the data the relevant columns, of course, renaming where appropriate, because we know that the delays from the data are actually like the previous delays, while for the predictor output, we want to call it like the forecasted delays, right? And we're getting the testing data frame which is split from the training data at a certain timestamp. So I believe in this case we have 2 months worth of data to predict for. And yeah, so we are actually joining the testing data with the predictor output. And this is now executing. If I go to the shell of MindsDB, you will not, like, you will see that we're doing some casting behind the scenes and preparing the actual output here. Long story short, you will get a table back like this, and the table contains, if we go to the top, it has the date, the carrier, and the previous delays, and then the predicted or forecasted delays 1 time step into the future in this case. So okay, all's good here, but we actually want to visualize this and see, get an intuition for how good the predictions are. And now, given that this is like an SQL table, you can very easily use external BI tools, business intelligence tools that support SQL databases like MariaDB. So one such tool is Superset, which is right here. Actually, it is an open source tool, and you can import or connect to a database like MariaDB right here. Then you can select datasets from it. Here I have a few of them. And finally, you can generate charts and group them into dashboards, which is precisely what I've done here. I have a dashboard prepared for this webinar. And here we can see 3 of the groups. That in green, you have the actual series, and in purple, you have the predicted T+1 forecasts that the MindsDB predictor produced. And in this case, for the carrier AA, DL, and OO, but it is trivial to add a new one. We just, we go to the Explore, which is like this view lets you modify the actual chart. And in this case, you can see we have a filter here for carrier equals something. And here we can add a different group, which I know WN is a group that is relevant for my insights right now. So I just change the filter here. I run the query and I get the new forecasts directly from the database. Now I can save this as a new chart and add it to the dashboard. And just like that, we now have like a new view in the dashboard, which we can move around and group all of the insights that we get from the data in a single place. So I hope this has shown how relatively painless it is to do machine learning from the data layer using MariaDB and MindsDB in combination. This is, I would say, a very interesting use case, and we're excited for the community to try it out and let us know what they think of it. So we encourage you to try it out, and feedback is always appreciated. Even if you want to contribute, we're open source, so that is always an option. So having said that, I am now, and well, Jorge and Vicentiu, we will be open to questions you might have. So thank you very much for your time and attention.